Namaste student, this is Sanjay Nath. Today's session is on rocks, chapter 6, ICSE Standard 9, part 1. Look at this introductory visual. This is not artificial, this is natural. This is called the painted hills. As you can see, there's a bands of color seen over this hill. This bands of color is due to the different proportion of mineral present at different time. Now this is bent due to the tectonic moment. Before we learn about the rocks in detail, let's see the wonders of nature. Look at this wonderful pebbles. These pebbles have different tones of color. These colors are nothing but the mineral present in different proportion. Now we'll learn about rocks and minerals in detail. Rocks. Rocks are our world. The planet Earth is essentially one big interesting rock. Inside it is molten, outside it is solid. At times it is also called the third rock from the sun because Earth is positioned third from the sun on its own orbit. The multifaceted rock that we live, that is mainly on the earth crust, it supports life in many ways. Many a time we say that the rocks are not having life, but life has been supported by rocks. Yes, when the rock gets disintegrate, weathered, it gives birth to the enriched nutrient soil that supports life on planet Earth. Rocks can be found beneath the ocean. It is also found in desert. It is also found in the high mountainous region. Are the just few of the ways the rocks emerge and support life. Now we'll learn about rocks and minerals in details, the in-depth study of rocks. The earth crust is made up of minerals and rocks. These are the three pictures of different minerals. This one is olivine, mica and quartz. As you can see in this picture, all these minerals are made up of individual crystals and they're made up of same element. Now we'll see the three different types of rocks. These rocks are mainly the combination of these minerals. Could be more than one or two minerals. One can see a lot of different minerals present in these three rocks. These are the minerals present in the rocks. This is granite. As you can see in the granite rock, the pink color, black color and the white color, these are different proportion of mineral present in the rock. This rock is called Igneous Rock. Second one, this is gneiss, or the pronunciation is nice. The white color part represents the quartz mineral, the black represents the mica or the golden color. This rock is basically formed due to the metamorphism of granite rock. Coal. Coal is basically sedimentary rock and it contains more of carbon. Now you might be wondering from where these minerals come from. Remember one thing, these minerals are mainly inorganic in nature. Minerals crystal can form in two main ways. When the magma from inside the earth will spurt out and it managed to break through the earth crust through the crevasses, fissures and the vents, the lava solidify and crystalline in new rock called igneous rock. Due to the solidification of molten material on the earth crust will form minerals. Simultaneously inside the earth, when the magma solidify in the magma chamber, it also form minerals. The another way of formation of mineral, the rocks on the earth crust when they subject to gradation by the wind, water and ice, primarily by water in action. Water dissolves the weak mineral and they deposit near the coastal areas or in the ocean and they give birth to evaporates. When the water get evaporate, the mineral that left behind are rock salt or gypsum. After knowing about how and where minerals are formed, now we'll learn about other characteristic features of mineral in detail. A mineral is defined as a naturally occurring inorganic substance which has definite physical and chemical properties. Please do remember, these minerals that present in the rock, they are not organic, they are inorganic in nature. Minerals may be classified as silicates or non-silicates. It depends on whether they consist of silica or not. There are 5 important types of mineral present on the earth crust at various proportion in different rocks: quartz, feldspar, mica, calcite and clay. A rock is defined as an aggregate or mixture of different proportion of mineral. Granite is the best example. Granite contains quartz and feldspar and even mica. For example, marble contains calcite, CaCO3 and quartz. Now we'll look upon rocks. A rock is described as an aggregate of minerals in varying proportion. As you can see, this is a sample of granite. Now granite is an igneous rock. As you can see, these crystals are visible here: white, pink and black. The white part is primarily the quartz mineral and the tinge of pink color is represent feldspar and this black color and golden color represent mica. Now this granite rock is having combination of three minerals: quartz, feldspar and mica. We normally identify the rocks on the basis of the following: the color of the rock, the texture of the rock, and the mineral composition. Primarily, the color can be identified by observation beneath the microscope or with the naked eye. The texture of the rock can be identified using certain technique or machines and tools. Mineral composition of the rock can be identified with the help of chemical reactions. Now we'll take the example. A rock such as granite may be composed of pink feldspar, that I have already told the pink color is a feldspar, and the white color in this rock is quartz, and the golden black color in this rock is mica. Now granite rock is a coarse grain. Granite is basically intrusive igneous rock, and due to slow cooling of molten material it formed. Because of this, the grains are larger in size compared to the extrusive rock. Now, these crystals are clearly visible. On the other hand, a rock such as obsidian, here's the obsidian rock, is a very interesting rock. It may be glassy and black with no mineral crystals visible to the naked eye. These rocks are formed due to the sudden cooling of molten material, primarily beneath the ocean. After knowing the basic characteristic features of minerals and rocks, now we'll understand how such rocks form. Now this slide is intended to help you to understand the important types of rocks. Now with the help of this diagram that represent the rock cycle, a scheme that represents the processes of continuous change that connects the three major groups or genesis of rocks as follows: igneous rock, sedimentary rock, and metamorphic rock. It will also show the two important parts of the rock cycle, that is sediments and molten material. Molten material can be categorized in two parts: lava and magma. Lava is a molten material that present on the earth crust, and magma is a molten material that present inside the earth. Now we'll understand the rock cycle in detail. On earth crust, the rock cycle plays a very important role, and it gives birth to different types of rocks. Now in this rock cycle, you can see the three groups or genesis of rock: igneous rock, sedimentary rock, and metamorphic rock. All these three groups of rocks are interconnected. Let's have a look. As you can see in this picture, when the magma uprise towards the crust, it may get locked inside the magma chamber and solidify. It forms igneous intrusive rock. When the molten material solidify on the earth crust, it will form igneous extrusive rock. Now let's have a look. When the granitic magma solidifies just beneath the earth, it will give birth to granite. As you can see in this granite rock, the large crystals are very prominent. These crystals are mainly made up of different types of minerals. Black represent mica, white crystal represent the quartz, and the light pink color represent feldspar. Now these minerals are quite visible. This rock is formed due to solidification of molten material just beneath the earth crust. Now due to slow cooling, it has formed large crystal. Now due to intense heat and pressure, this granite rock may convert into a metamorphic rock. For example, granite can convert into a new rock called gneiss. Now both the rocks are a very good example of igneous and metamorphic rock. Now we'll see another example when the granite rock may uplifted due to tectonic movement, and they'll form an outcrop. Now such rock, when they're subject to weathering and erosion by the agents of gradation, they'll give birth to sediments, and these sediments have been transported by either wind, water, and ice. When these sediments get deposited layer by layer due to compaction and cementation, they give birth to a new rock called sedimentary rock. The best example of sedimentary rock is sandstone. When the sandstone in the rock cycle further gets subject to burial due to heat and pressure, the sandstone in the course of time will convert to a metamorphic rock. Now, in this manner, we can understand here the rock cycle is a continuous process. Now this metamorphic rock can be further get buried to form a new metamorphic rock. Even the metamorphic rock gets subject to uplift due to tectonic movement and form an outcrop, and it may subject to weathering and erosion and form sediment. Now these sediments compacted and cemented to give birth to a sedimentary rock. So in this manner, all three groups of rock at one point of time will convert to sediments. So this cycle is a continuous cycle and that give birth to different types of rock. Now we learn about the classification of the rocks on the basis of their origin and their subtypes. Igneous rock is the first type of rock that formed due to the solidification of magma on the earth crust or inside the earth. There are two ways they solidify, either intrusive or extrusive. Now we'll see the examples of intrusive igneous rock: gabbro, diorite, granite, and granite. And extrusive rocks are basalt, andesite, dacite, and rhyolite. These are different examples of intrusive and extrusive igneous rock. Now we'll see how the sedimentary rocks has been classified. They classified on the basis of their formation. The first type is clastic, second is chemically formed, third is biologically formed. Clastic rocks have large or small clast or the parts of rocks. For example, conglomerate, breccia, sandstone, siltstone, mudstone, and shale. These rocks are formed due to the cementation of the large and small particles of rock fragments. Now, sedimentary rocks also form due to the chemical action or chemical precipitation. Examples are limestone, dolostone, and evaporates. Examples are rock salt and gypsum. Sedimentary rocks is also formed in biological manner: coal and chert. These are formed due to the decaying of dead remains of plants and animals. Metamorphic rock. Metamorphic rock is a rock formed due to the heat and pressure of either any one of this rock type. There are two ways the metamorphic rock can be classified, that is foliated and non-foliated. Foliated means what? When they break, they always break in layers like slate, schist, and gneiss. Non-foliated, one cannot see any layers in these rocks, mainly quartzite and marble are the best example of non-foliated rocks. Now we'll understand what are the common rock forming minerals are: quartz, feldspar, mica, calcite, and clay. Quartz mineral, most commonly found mineral in all the rocks. They have shades of white, grey, and pink, mostly colorless with glassy luster. As you can see in this picture, this is a pure quartz mineral. Feldspar, found in the rocks like granite and basalt. Color may vary as K is replaced by calcium or sodium. K is potassium. The weak mineral, when they wash away and they are replaced by calcium and sodium, they have a different tint or color. K feldspar is pinkish or whitish, while calcium and sodium, when replaced in the rock, the feldspar will be green or black. Other common rock forming minerals are mica. As you can see in this picture, the lustrous, shiny, glassy material is mica. Mica appears white or colorless, and they have flakes in granite and as black needles in basalt. K's may be replaced by calcium or sodium. Calcite occurs in rocks like limestone and marble. It is primarily colorless or white and crystalline or amorphous. The last important common rock forming mineral is clay. Clay is similar to mica as it occurs as the thin layers differ as it has higher water absorption capacity. The clay can absorb as much as water and retains the water for a longer period of time. It found in the rocks like shale and conglomerate. They act as a binding material. Now we'll learn about the different types of rocks. The first group of rock is called igneous rock. Igneous rocks are also called the fire rock because it is formed due to the solidification of molten material on the earth crust. It is also called the primary rock because all other rocks are the derivatives of igneous rock. Now understand how these rocks are formed. It is formed due to solidification or crystallization of molten materials or minerals. There are three ways by which igneous rocks are formed: extrusive, intrusive, and hyperbasal. Extrusive rocks, when the molten material solidify on the surface of the earth. Lava hardens to form extrusive rocks. Now these rocks have tiny or fine grained crystals. They are glassy in nature and the texture is fine grained. For example, basalt. Intrusive igneous rock, the name itself suggests that such rock formed due to solidification of magma beneath the earth crust. When magma hardens to form intrusive rocks, their grains or crystals are easily visible. They are called coarse grained rocks or their crystals are larger in size. Example, granite. Hyperbasal rock formed due to the cooling and solidification of magma within the cracks and fissures of surrounding rock. They'll form shapes: dike, sill, batholith, laccolith, etc. We'll learn about hyperbasal rock in detail in the next session. Now we'll see the features of basalt and granite rock. Basalt is a extrusive igneous rock. It is formed due to solidification of magma on the earth crust. They're dark in color, they're fine grained, and they're extrusive in nature. As you can see, this rock, basalt, the grains are fine. It is formed due to when lava erupt onto the surface and they solidify in contact with the atmospheric air. Most widespread igneous rock on the earth's surface. Granite is light colored and is coarse grained and there is no pattern. They're haphazardly assembled. Granite mostly contain quartz, feldspar, and mica, and hornblende, often used in construction purpose in buildings and in monuments. Now we'll learn how minerals and crystal formation took place in rocks. This is a 3D view of volcanic eruption, and this diagram will explain how mineral crystals form on the earth crust or inside the earth. Minerals form from hot magma as it cools inside the crust or as lava cools on the surface. When the molten material or magma cool inside the earth, the cooling process is slow. But due to the slow cooling process, the crystals of these rocks will form larger. Whereas when the molten material come on the surface of the earth in the form of lava, will form extrusive igneous rock. The lava cool down very fast. Due to fast cooling, it will form small crystals. When these liquids cool to solidify, they form crystals or minerals. The size of the crystals depend on the time it takes to crystallize into a solid form. Now we'll understand with the help of this example how mineral crystal size vary. When the hot material cools fast, it has smaller crystal size. When it cools slowly, it has a large crystal size. Examples: granite. As you can see in the granite, the common minerals are feldspar, quartz, and biotite. You can see the individual crystals are very prominent in granite. Due to slow cooling, the crystal size grow bigger in size. They are also called coarse grain. Whereas rhyolite, extrusive igneous rock, it is formed due to the solidification of lava on the earth crust. Due to fast cooling, individual crystals are not very large, they are fine grained. Now we'll learn about the third type of igneous rock called hyperbasal or intermediate rock. They are mainly formed due to the cooling and solidification of magma within the cracks and the fissures of surrounding rock. As you can see, the magma solidified in the cracks and fissures in horizontal as well as vertical manner. The magma cools down at intermediate rate, not very fast, not very slow. Therefore, the mineral crystals are intermediate in size and the resultant rocks are medium grain. Now we'll understand each and every shapes that form due to solidification of magma in the fissures and the cracks of earth crust. With the help of this diagram or sketch, we'll understand how the hyperbasal rock or intermediate rocks are formed. As you can see, when the magma get locked deep inside the earth in the magma chamber, they'll form large crystals. Now when the magma manage to uprise and solidify on the earth crust, they'll form fine grained extrusive rocks. When the magma get locked in the intermediate stage, they cool not very fast or not very slow, and due to this they'll form medium sized crystals. Now these shapes are formed due to solidification of magma, and there are different names to this. Now with the help of this diagram, we'll understand how hyperbasal rocks and their shapes form at the intermediate state. We'll also understand what are the different type of intrusive and extrusive rock will form due to solidification of basaltic and granitic magma. Now first we'll see what are intermediate rocks. If the magma gets solidified in uneven polygon shape, that shape is called batholith. If the molten material gets solidified diagonally between two layers, is called dike. If the magma gets solidified horizontally between two layers, called sill. Now we'll understand what are the different types of rocks will form due to the solidification of basaltic and granitic magma. If basaltic magma gets solidified deep inside the earth, it will form gabbro with large crystals. If the basaltic magma will reach toward the earth crust, will cool fast, will form basalt with fine crystal. If the magma get locked at the intermediate stage and solidify, the rock will form dolerite with medium sized crystal. Now we'll see when the granitic magma solidified deep inside the earth, it will form granite, will have large crystals. When the granitic magma managed to reach towards the earth's surface, it will solidify to form rhyolite, fine crystals. If the granitic magma solidify in the fissures and cracks of intermediate rocks, it will form pegmatite. In this manner, the different type of hyperbasal rocks and their shapes will form. Thank you for watching the presentation.